Right. Hi folks, how's everybody? My name's Dean Ward and I'm a developer on the architecture team at Stack Overflow. Here's the rest of the motley crew that runs the architecture team at Stack Overflow, also known as the purveyors of the finest bad ideas. Most of the things I'm talking about today have been invented by him or me or the other two that are pictured in this picture, and then implemented by various other engineers in the organization. I'm going to talk to you today about one of our products called Stack Overflow for Teams. Sorry, I have a ton of notes here and I'm just like nervous as hell, so just bear with me. And how we scaled it to relatively extreme multi-tenancy. So for those of you who are not familiar, we have a product called Teams. It's used for private Q&A. We have two tiers. We have an enterprise tier, which people can host in their own data center, or we host it for them in Azure. And then we have basic and business tiers, which are hosted as an embedded part of Stack Overflow. So when you visit Stack Overflow, you can get private Q&A from there. That's the bit I'm going to be talking about today because that's the bit that we host in our own data centers. And so that's the bit we care most about when it comes to performance. So to give you kind of an overview of the kind of scale that Stack Overflow is operating at, I'll run through some of the numbers here. We're dealing with about 8 to 10 billion hits a month at roughly 3,000 requests per second average. And we're doing that across just 9 web servers. Those web servers have like 48 cores in them and 64 gig of RAM, I think. But they're only operating at 10% CPU. So that's not very much. So in theory, we could go down to far less machines and still have the whole thing running. We don't try that often because it has occasionally caused an outage, so we don't do that. And just to prove I'm not lying, here's the graphs from the last 90 days. You can see we're averaging 3,000 requests a second, and this is the web tier's CPU average. And it kind of, the jitters all look roughly based upon the traffic. Now, our most rendered page, the question show page, which is the questions and answers that you see when you visit the site, that takes roughly 20 milliseconds to render on the back end. And that is literally hitting the database, grabbing the data, massaging it into view models, and then splurging it out onto a Razor page. There is literally no caching in that flow at all, and that takes 20 milliseconds to render for every single thing. And then from a data perspective, across the entire Stack Exchange network, so obviously we have Stack Overflow, but we also have things like Serverful and Superuser and bicycles and world building and all kinds of things. Stack Overflow itself has 46 million posts. That's questions and answers, whereas the rest of the network has about 17 million. So we're not exactly big data. We like to call it medium data, for want of a better term. The Stack Overflow database itself is about 4 terabytes. It's not huge at all. And then across the overall network, we have 400 sites. So like I mentioned, that's things like bicycles and world building. So there's about 200 sites, but then we have the meta sites, which is where everybody argues about everything. Yeah. And then one of the things that kind of keep this whole thing going at reasonable speeds is that we've had a historic obsession with performance. And so we consider performance as a feature. It's something we like to keep a close eye on. And the advantages of us focusing so much on performance mean that we can run on a lot much less hardware than most sites do. And that costs us a lot less money. Just a little anecdote. We have had such a crazy obsession with performance that once upon a time we were deploying, about 5 years ago, deploying new machines to the data center. And we deployed a service that normally runs on those machines, and we just weren't getting the kind of performance that we were expecting. And so Mark here went and dove into some code and started wildly optimizing all the things he could, algorithms and the way things interact with the CPU and all that kind of stuff. And eventually got it up to some kind of decent speed, but literally nowhere near the kind of speeds you'd expect for a 4 gigahertz machine. And upon further investigation, after banging our head against the wall a long time, she found that the machine had a BIOS bug which had throttled the box down to 133 megahertz. So I guess the advantage overall is that we now know we can run a data center on like 90s hardware, but yeah, we know that the tag server is going to continue to run well. Okay, so that's the overall numbers. I want to quickly take you through the architecture. I'm trying to set the scene here of how things look on the public side of things, because this also plays quite well into how we architected the Teams product. Now, when a user comes into us, it hits Fastly, which is our CDN, and Fastly forwards the request onto our HA proxy, which is this load balancer here. HA proxy TLS offloads the request, and it hits the web tier, which I mentioned before. There are 9 of those. And then the web tier goes and does all the things it needs to do, hitting various things. The web tier itself runs not only the Stack Exchange network, but it runs the talent and jobs product, it runs chats, and a whole bunch of other supporting applications, things like Calculon, which is our ad server, that kind of stuff. Over here, we have the service tier, which is behind another load balancer. That's currently 3 machines. And that hosts kind of internal-only services that are consumed by other parts of the applications. So things like Stackmail, which sends emails. All outbound email goes through that. And we have the tag engine, which I just mentioned. That's used for when you visit a question page on, say, Stack Overflow, it runs a query against the tag engine. And then it also has things like Provenance, which is a kind of data analysis engine. It analyzes our traffic so that we can target job ads and all that kind of stuff appropriately. From a database perspective, we have quite a few SQL databases, but the primary ones over on this side, the ones that are serving the sites, are running SQL Server, I think 2017, using availability groups. And so we have a primary node, which is servicing reads and writes, a secondary node, which is servicing just reads for stuff that we don't necessarily need to care about, timeliness of data and things like that. And then we have another secondary in a replica data center, so that if this whole data center goes offline, we can go and fail over to another one. And then, sorry, screen's about to turn off. And then for caching, we use Redis. We also use Redis for distributed locking and things like queuing and stuff like that. And then we use Elasticsearch for full text search purposes. And from, I know I've missed a thing, sorry. Oh, and then, as I mentioned, we have a replica of this whole thing in another data center. The primary data centers, all the servers are prefixed with NY, but they're supposed to be in New York. It's actually in New Jersey, and we just never got around to changing the names. The other data center is in Colorado. It actually has less machines because it turns out it costs a whole lot of money to maintain an absolutely identical infrastructure elsewhere. Okay, so when it comes to Teams, we have a whole bunch of different challenges. The biggest one is security. The public Stack Exchange network is kind of all pretty open. We do public data dumps of the data, so those all get shifted out to archive.org, and the public can consume big data dumps of stuff. And most developers that work within Stack Overflow have some level of access to the public kind of servers and things. That's so that they can do their jobs effectively, like diagnose issues, that kind of thing. But Teams has this whole different set of challenges, notably that customers expect their data under lock and key. They don't expect any developer in the organization to be able to access the stuff. So we need a kind of separate area where we can make sure the data is locked down, that there are infrastructure kind of rules to make sure that just random people can't go and look at stuff, auditing and all the other kinds of things. And then there's a whole bunch of application level stuff that we need to care about. Does this particular user actually have access to this thing that they're trying to access, that kind of stuff. And so we need to work out how to create an architecture that supports that. The next big challenge is that engagement is important. We want users to keep coming back to their stuff. And so we figured the easiest way to achieve that would be to make sure that Teams is embedded in Stack Overflow. I'm just going to quickly nip out the slides here to show you what I mean by that. And for some reason, this is misbehaving. When I say embedded, I mean this is Stack Overflow itself, and then the team is literally in the Stack Overflow Chrome, and so you get all the regular kind of things that you get, like inbox messages and achievements and all the other things. You can search across multiple sites, all that kind of stuff, without actually leaving Stack Overflow. You can see the address up there is stackoverflow.com, and my random production test thing that I mess with. Let me just zip this back on. That embedding, however, comes with a cost. We have to somehow get that stuff over into the Stack Overflow stuff on the public side of the network efficiently. And doing that efficiently is a hard problem. And you would not believe the terrible ways we came up with to fix that. The next big problem is scale. We need 10, like up to 100 to 200,000 tenants and possibly more in the coming years. So we need to be able to handle a ton more scale in terms of individual things than we do for Stack Overflow. Now, the big change here is that whereas a Stack Exchange site, a public one, has maybe tens of thousands of posts or millions of posts, these tend to be a lot smaller. They're like thousands of posts or hundreds of posts, but we just have a ton more of them. So we need to work out how to deal with those elements of scale. And we got to do all this on a tight budget. When we were building this, we didn't have any budget to buy kit. So we had to make do with what we had and work out how to deploy this in a sane way with minimal amounts of dollars. Okay, so this picture we're familiar with. This is the public side of things. And for teams, we're introducing an entirely new network, because hell, why not? You'll notice that it's pretty much the same as this part of the network. There's a few less machines, a few less SQL bits and all that kind of stuff. And there's less web servers and less of everything, generally. But what we're basically doing is introducing a firewall, which provides our access control. This literally only allows HTTPS in. And then between all the services in here, we only allow TLS to chat between the things. Which is not necessarily the case over here. We're still kind of rolling out TLS between our internal services on the public side of things. Literally anything that has private data lives in this secure network. There's a handful of employees at Stack Overflow that can go anywhere near this network. I think it's like 5 people. And anything that touches a team, so we're talking like if you get an inbox message from a team member, or if there's any Q&A content, email messages, all that kind of stuff, that all lives in here. The architecture itself is fundamentally the same. We have a web tier. It has less applications. Obviously, we don't need things like talent and jobs and all the other bits and pieces there. But we do have things like the tag engine, a stack mail instance, other bits and pieces over on this service tier. So the architecture is quite similar, but the biggest difference here is all of this is running on VMs. The one exception is SQL, and the reason that SQL is running on physical hardware, well, I say that. When we built it, it was running on VMs. The performance was abysmal, and so we had to buy hardware. And so we get fast local SSDs and a ton of memory for the number of teams that we need to deal with. Okay, so that's the architecture. But how the hell does all this stuff work? This is where things get a little bit hairy. I mentioned that we were embedding this thing in Stack Overflow, and most people would do this in a particular way. Let me go through how we did it, because it's stupid and we'll probably regret it for the rest of the time. A request comes in from a user to something that's in a team, and it hits the public network, the DMZ, and then some authorization checks are performed. And assuming those are all successful, we go and add contextual information to a request that we're going to send elsewhere. That contextual information is things like, who is the user asking for the thing? What team did they ask for? And various other bits and pieces that we just need to forward on for kind of bookkeeping purposes and stuff like that. We then forward all this to the CFC. And because we never, ever trust anything that's come from the DMZ, because it could be compromised or something like that, we don't know, we go and check everything again. If this fails, get out. We're not going to show anything to you. An audit log will be written, and in the case of this, then a log will be written to our logs, and a developer has to investigate it. Now, once we've got authorization right, we switch into the right context. And then this is where things get crazy. We execute the request and render the output exactly as though it was a regular web request. So if you imagine a request to, say, a Stack Overflow question, it executes the request, it renders a razor view, and then it dumps it out into the response. We're actually doing exactly the same thing here. We're executing the request, we're rendering the output. The code underlying this doesn't know that it's a kind of proxied request. The key thing here is the instance of that's running on this web tier is actually another instance of the Stack Overflow application. So we're running it in 2 different networks, and then running this. Then, so that renders out like this. We got sections and just regular Razor stuff. Then we go and cherry pick the bits that we care about, that we want to interleave into the Stack Overflow Chrome. I did mention this was crazy, right? And then what that effectively looks like is we're transforming the stuff that's coming out from this secure network into a kind of delimited set of stuff. It's not actually a HTML comment. We're using a delimiter, which is lovingly referred to in code as banana split. I haven't put the actual child that is there because I'm not sure if it's a security concern or not, and I need to go and review some code when I get back to a computer. Yeah, this is, we're sending that back over the wire. So that gets back to the DMZ, and then the DMZ starts to stream each piece of the delimited sections into the right part of the output on the other side. Now, this is insane, right? Why would we do it like this? Why would we not just use an API like everybody else in the world? Because of the kind of scales we're running at, we're really try to keep allocations low. And so what we're doing is we're actually sending this stuff over the wire as bytes, and then reading those bytes out, allocating as little as possible. I think we're like 1K chunks or something like that, and streaming those back out into a regular full layout for Razor. This means that we're keeping our allocations very low, which means we also don't store, we avoid the large object heap. When you use an API, you've got to serialize on the way out, potentially ending up on the large object heap if it's a particularly large blob of data. You've got to deserialize it on the way back in, and then you've got to do stuff with it. We're avoiding the large object heap by doing this streaming side of things because the bytes, which are then converted into Unicode characters, are ending up straight on the page. This also helps us avoid GC stalls. At the kind of scale that Stack Overflow is operating at, if we get GC stalls, we start to get requests piling up. Remember, this is 3,000 requests a second, and we get requests piling up, and then that kind of cascades into failures all over the place, and then you end up on an outage, and we all end up on a hangout trying to work out what the hell happened. But there is a problem here. This approach is very tightly coupled. The picture that I showed where we had the delimiters, hopefully we can get back to that easily. This guy over here, oops. This guy over here. We are incredibly dependent on the order of these things. If we deploy a change which needs to add a new thing to this delimited set of stuff, we're going to have problems. We could fix this by introducing versioned headers and all that kind of stuff, but we actually have plans to fix this long term in a much better backwards and forwards compatible way. But for the moment, we're stuck with this nightmare thing that we've invented. And yeah, you could call it tech debt, I guess. It certainly smells like it. But we do have plans to fix it, so that's good news. All right. The next thing with Teams is sharding. Now, this is kind of obvious. If you've done any kind of like hundreds of thousands of tenants sort of stuff, you have to care about sharding. We shard in 2 places. We shard in SQL Server, and we shard in Elasticsearch. With SQL, we originally tried to shard based upon databases. If you go into SQL Server and create 10,000 databases, everything breaks. If you have availability groups, they don't replicate anymore. Your tooling just literally freezes. You expand like the databases node and it takes 50 minutes to render. And a lot of other tooling like backup stuff and anything that needs to deal with large quantities of things just breaks down. This is definitely the road to hell. The way we address this is we have schemas which are locked down to particular users. So a particular team can only access a particular schema. And we have like 10,000 schemas in a database. This gives us a single kind of, in the event that a database dies for some reason, we just go and restore that particular database. So we're only dealing with 10,000 things that could be broken. And availability groups just work because we only have, say, I don't know, 200 databases rather than 10,000. Tooling functions, more or less, still don't expand the tables node in SSMS, it breaks down. But other than that, everything seems to kind of roughly work. The biggest thing with schemas is the tooling for them is not as good. So you can't just go and say restore an individual team very easily, because you have to go and kind of deal with security permissions and all other kinds of blah, 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 just to get the data back from a particular point in time. It's still a little bit of a nightmare. Our DBA, Taryn, hates us if we mention the word restore in any sentence whatsoever, but overall, like, it's better than databases. Elastic's a similar situation. We try to create thousands of indexes in Elasticsearch. Elasticsearch doesn't like it. It starts to get kind of angry maintaining so many Lucene shards. The more servers you have, the more Lucene shards you have, and then Elastic spends time maintaining metadata for those things and all that kind of stuff. And so what we've done instead is, again, we've sharded 5,000 tenants into an individual Elastic index. That means we have, say, 200 indexes rather than gazillions. Excuse me. And so we've got indexes with 5,000 tenants in them. We use filtered aliases to make sure that we're only getting the data back we expect. Filtered aliases aren't particularly secure. With the way Elastic is kind of built, unless you've got extra plugins to secure it, you can tweak aliases. That could potentially mean that somebody could perform a search and some malicious party has tweaked the underlying alias. And so we also perform checks at the application level to make sure that the data that we're getting back is actually for that team. If it isn't, no go, you don't get the data. So just to give an indication of how bad Elastic is, this is the point in time when we actually made the changes from sharding, and you can see Elastic CPU was just crazy. Now it's pretty much the same all the time. No, you can't do that. Go away. Right, fine. God knows what that is. The next one is security, and I've completely forgotten everything I was going to say for this slide, so I'm just going to quickly zip there. Okay, grand. Security is kind of a bunch of stuff that I mentioned before. We authorize on the way in. We authorize on the way into the secure network. We don't let anything out unless it has been allowed, and everything is default deny. So anything goes wrong along the way, bam, you're done, and we log an event for a developer. So authorization checks everywhere. There's very limited access to the secure network, a handful of employees as usual, and we audit everything. Any traffic that comes into Stack Overflow is logged to a whacking great big gazillion terabyte traffic logs database. And similarly for channels, we log everything as well. Now, we obviously can't record post bodies. That would be insanely kind of storage expensive and has GDPR concerns and all that kind of stuff. We do log every single bit of metadata, so we know this helps us do things like spam checks and all that kind of stuff. But it means that we also have a very, very solid log of everything. Similarly, we have audit logs for getting into the secure network and SQL audit logs and basically audit everything. And then this is a fairly big one. Troy Hunt has some pretty good blog posts and all this kind of stuff, but we only ever render trusted third-party JS on the site. I'm sure most people probably realize this. They realize it when it's said, but if you put third-party JS on your site, it can do anything that your user can do. So it's running in the user's context. This means they can exfiltrate data from your site. So if you are a member of a team on Stack Overflow, they could go and get everything and send it to a third party. That's not a good place to be. So we have a handful of things that we actually trust. We do use Google Analytics. It's very, very heavily sanitized. We don't send any actual content up. It's literally just metadata. So even URLs that might have, typically in Stack Overflow, a question will be like /q/1/ my awesome question title. But in Teams, it's just /q/1. So none of that stuff ever goes anywhere else. Any other things? We have integrations with things like Teams and, Microsoft Teams and Jira. We have verified their JavaScript, and we pin ourselves to one version, and then we use sub-resource integrity tags to make sure we only ever get that version. So we know for a fact that even if that JS was compromised, that script would not load and it can't do anything bad. And finally, we only use trusted third-party JS on the team side of things. And so that means ads, which are our sandbox on Stack Overflow. They're running an iframe and things, but it's just not worth the risk that there could be a compromise. So we just don't allow ads at all. And then the next one is scale optimizations. So I mentioned that 100, 200,000 teams. Now, that's all well and good. What we found is we were quite nervous because we're running all on this virtual machines. But what we've kind of found is that overall, individual teams actually perform quite well. They kind of have similar latency and similar performance characteristics as a public Stack Overflow instance. We thought that maybe running stuff on VMs would have like a negative effect. Where we have found problems is anything that goes across every single team in the infrastructure, it's horribly slow. Anytime you need to enumerate anything is just painful. You can do some of this stuff in parallel. We haven't got to that point yet because what we decided was that a lot of operations that we perform that need to go over everything, things like awarding badges to teams, say indexing posts into Elasticsearch, or sending newsletters, all of these things only really apply when the team has had activity. And typically, teams that have had activity within a particular threshold is a way, way lower number. You're looking at maybe, in our case, say 25%. So we can do far, far less work because we don't have to go over everything. For each kind of operation, for example, badge awards, we might only need to consider teams that have been active in the last day. For something like sending newsletters, maybe teams that are active in the last week. And for something like indexing Elasticsearch stuff, we're probably thinking, stuff that was active in the last minute, 2 minutes, something like that. So we limit to those with activity. The other thing we came across, SQL Server has a hard limit of 32,000 connections. If you get to that point, everything breaks, literally everything. And the reason that you can reach that limit is that if you use pooled connections, you're actually maintaining a connection to the SQL box for forever, more or less, until it decides to clean them up. If you use pool connections, then when you open your connection in dotNET, it's going out to that pool, it's grabbing the thing which may already be open, and it's using it. And then when it closes it, it doesn't really close it, it just throws it back in the pool, and it still has a hard connection to SQL Server. When it comes to these operations that go across all the teams, we started to use unpooled connections. Now, that means that we hard open and we hard close at the end. That's great, but it does have a minor performance impact. But fortunately, pretty much, no, actually all operations that need to run across all teams actually don't all run in the background. And so that kind of performance degradation at the start and the end doesn't actually have that much of an effect once we kind of limit it down to only those with activity. So you can see here, this is the point in time when we eliminated the hard connection, the pooled connection stuff, and you can see that now SQL's kind of bubbling along at, I don't know, what's that, 500-600 connections constantly. So that includes kind of regular traffic, which is using pooled connections, and then a whole bunch of like unpooled stuff that's running in the background almost constantly. So that's kind of how it all works. I mentioned some thoughts we're having for the future. This isn't directly related to Teams, but we are just on the verge of finishing our port to dotNET Core. We're going to probably ship on, I think, 3.1.2 when it comes out for Stack Overflow, probably in the next month. The reason we're not going with 3.1.1 is there's a weird like assembly binding thing, I think, or something like that. And 3.1 actually has a security issue in Kestrel, which is just not worth the risk. So probably going to go with 3.1.2 when it releases in February. This gives us a whole bunch of cool stuff. For Stack Overflow, we can start to run in containers and in Linux. Now, this isn't a big thing for the public sites. The reason it's not a big thing is that we already have this in data center stuff. Moving to containers for all that just doesn't make sense right now. It's a lot of work for not very much gain. Where this does make sense for us is in our enterprise environments. We can just deliver a single package. Customer can go and throw it in their own Azure instance, or they can go and throw it in their own in-premise. They can go and throw it anywhere. And Linux primarily because customers don't want to run Windows, quite frankly. So we want to get them running on Linux instead. The biggest thing that we think we're going to find there is going to be paths. We reckon there's going to be backslashes everywhere, and we're going to be finding backslashes until the end of time. The next thing is gRPC. I mentioned that tight coupling between the secure kind of network and the public network. We think we can get rid of that whole awful mess by introducing a gRPC-based API between the two things. gRPC is based upon protobuf, so we can use backwards and forwards compatible API kind of constructs for that. And Mark's looking into this soon, so I'm not sure exactly where we're going to go, but we're going to try and work out if we can do some kind of streaming so we don't have allocation problems and all that kind of stuff. And then the next one, which is not a primary driver for .NET Core 3, is performance improvements. We have shipped a couple of things already. This is the Stack Exchange API, and you can see when we shipped it around mid-December. Other than that crazy tool spike there, which we'll ignore, pretend it's not there, our CPU usage has gone way, way down. And similarly, when we deployed stackexchange.com, again, and these graphs are terrible because there's a big spike there and then a big trough here. I think this was when some monitoring broke. Again, far, far lower CPU. We suspect that if we port all the things to .NET Core 3, we're going to go from 10% CPU average to something even lower. That's not a bad place to be. And then finally, addressing long-term scaling. So I mentioned just a throwaway number of 100 to 200,000 teams. This is something that the business has been asking us to be scalable to. What does that look like long-term? What happens when they want 500,000 or 1 million? We are running on in-premise hardware. At this point, it's 5 years old. We're getting to the end of support contracts. We're getting the end of firmware support and all these kinds of things. This is not a great place to be. It means that we're probably going to have to go and buy a whole raft of hardware at some point. So do we need to start looking into the cloud? Do we need to buy more hardware? The cloud itself has a whole bunch of problems in itself. Because we're running in-premise on our own hardware with our own networking and all that kind of stuff, there's no contention. Latency is crazy, crazy low. And because the two networks are like literally next to each other with just a firewall in between, our latency between these apps is like really, really fast. We go to the cloud, we're all of a sudden introducing latency. Does that have a compound effect of we start to fail in places that we didn't expect before? And so it's possible that we're going to start looking into what Stack Overflow on the cloud looks like, what Stack Overflow Teams looks like in the cloud, that kind of thing. So that's that. We did end up making a 10-year-old monolith, terrible old 10-year-old monolithic code base, work for this kind of crazy new set of things that we need to do. And it hasn't been too painful thus far. So any questions?
So you kind of articulate all the issues you've got around SQL and servers and stuff.
Yeah.
Presumably you've looked at some of these so-called NoSQL solutions.
So internet scale databases, yeah.
Whatever those are. Presumably you've had a look at some of those.
The problem is we have years of historic data that we need to migrate. There's a huge cost in kind of doing any kind of migration to these things. I don't think NoSQL is a fit for the kind of stuff we want to do. And I don't necessarily think you may gain performance, but you lose some things like atomic guarantees and all other kinds of stuff. So we haven't investigated it fully. It's not to say it's completely ruled out, but I think we have a lot of expertise in SQL, and so maybe scrapping that isn't the best way forward.
But is the kind of operational pain? I mean, maybe I'm misinterpreting
No,
some of the stuff you were
there has been operational pain, don't get me wrong, but it's not severe enough that we would actually consider an alternative at this point, no. Yeah. Any other questions?
Do you have any replicas of that production environment?
Yeah, sorry, that the team's secure environment is also replicated to that other data center that's over in Colorado. So again, it's largely VMs with the SQL servers. There's just one SQL server over there, and that is it's set up as an AG as well. And so everything goes from the primary through to the secondary in the primary data center, and then it goes out to the secondary data center as well.
How about Stack Overflow?
Stack Overflow, yeah, same thing. The Stack Overflow database has a primary and a secondary in the main data center, and then that's replicated out to the secondary, and it's basically exactly the same setup.
Any other environments before you go to production?
Yeah, we have a dev environment. We're actually actively working on our kind of CI/CD pipeline, so we're kind of starting to look at PR environments, that kind of thing, and test environments, but we're still kind of a little ways off from that yet.
How many releases do you do per day?
Say we deploy, 3-4 times a day at least?
At least.
Yeah, at least 3 or 4 times a day.
Do you do any canary releases?
Okay, so when we deploy, there's a 3-stage process. We deploy CI builds, go directly to our development environment. We use PRs a lot, but we don't currently have PR-based environments yet, so we tend to run tests and things against the PR environments prior to them going into master. Once dev is smoke tested and made sure it's looking good, we go to the meta environment. So meta.stack exchange and meta.stack overflow are both our canary environments, because historically those have been very vocal users that are like, hey, you broke everything. So that's our canary. And then once that's confirmed sane and we don't have a ton of exceptions in the log, that will go out to production. So all in all, that process takes, I think, 9-10 minutes to go from dev all the way out to production. And we do that like 3 or 4 times a day, maybe more sometimes, depending upon what we're shipping. Yeah. Hey.
So I'm intrigued how you query across sort of thousands of schemas, whether you do it sort of set based with a block that sits above them, or generate dynamic stuff, or you get lots of code making lots of connections.
So because the schemas are all access controlled individually, it's literally open a connection to the particular schema, close it down, do the next one, over and over and over again. Now you can parallelize that, but in our case it's a lot easier just to deal with the things that actually have activity. Yeah. Hi.
Okay. So you said you're upgrading from dotNET Core 3.1.
Yeah.
What version are you upgrading from?
Oh yeah, sorry I didn't mention that. The Stack Overflow application is currently .NET 4.7.2, full framework running on Windows. And yeah, I think Samo, one of the members of the architecture team, I think we have a build running on dev. It's not production ready yet, so we're probably looking in the next month to actually start to canary that out to production.
Did you go through a lot of pain to get to that?
It's just been a lot of repetitive stuff. There's been kind of lots of small changes over the past. There wasn't any dedicated time to it. So like Mark and Nick and Samo have been working on the open source libraries to kind of get those to net standard. And then once that was there was a bunch of changes, and it kind of happened just really slowly. But in terms of moving to .NET Core itself, it's been fairly pain-free. We've had to deal with a lot of abstraction kind of work to make sure that we can run on MVC 5 and ASP.NET MVC Core. And the other things are like, we had to ask the Microsoft teams to add some stuff like, we used @helper syntax in Razor quite a bit. And so we needed an equivalent of that in .NET Core. So we got on a call and just said, hey guys, can you do that for us? And they did. So yeah, it's not been a huge amount of pain. It's just been quite long.
Sounds similar to us.
Yeah.
Same thing.
It's just a lot of repetitive work to get everything over, that's all. Yeah. Did you have a question?
Yeah, you mentioned, maybe you don't want to answer this question, so feel free to pass.
Sure.
You mentioned earlier on that you didn't have any budget to doing this sort of stuff.
Yeah.
Why didn't you have any budget?
This was kind of just throw a thing out there and see if it would be successful. And so we had a small team of people kind of working on the code side of things, and then actually scraping together the budget for the machines, it wasn't there at first. So we had to do it on our existing virtual machine infrastructure. Then when we got to the point where we were starting to see success, we got budget to buy SQL servers, and then as things go forward, there'll be more budget for other things. It's just, we're not sure whether it's worth buying machines at this point or whether it's worth like doing a cloud move or what. So there's a whole bunch of kind of analysis work to do before we get to that point.
So this wasn't like a commission feature?
It has a funny kind of history. It was a bunch of people working on the enterprise product, which only got reincarnated like 2 or 3 years ago, just working out whether we could do a similar thing on the public site. And then as it gained traction, it got more developers allocated to it until I think like 2/3 of the engineering division were working on it, and then it shipped. So to say there was no budget is not exactly right. There wasn't budget for hardware, but there was certainly budget for engineers to work on the thing, you know? So, yeah. Hi.
So you put a .NET Core, right? Did you
Sorry, I couldn't hear that.
Consider any orchestrators only,
Orchestrates Kubernetes, did you say? We're starting to look into Kubernetes for deployment onto the enterprise side of things once we're starting to look at containers and stuff. But for the production side of things, it isn't worth it yet, and it may not be something we really look at until we consider what the next options are with like where we go in future. So until we have everything on .NET Core, we need to work out what the next steps are yet. Yeah. Is that? Cool.